Okay, so you can watch this letter also through YouTube. So now we have discussed the many points about the uh, basic criteria about proton and NMR spectroscopy, and we were discussing about the most important point, which is responsible for deciding or by which we can decide the conformation of the molecule, and we can also find out the orientation or stereochemistry of the molecule. So far, by using the coupling constant value, J value, we learned that how to tell about the type of spectrum AM, AX, AB type, and how to find out the connected or neighboring proton just based on the basis of the coupling constant value. So now, next part is what the Karplus curve and dihedral angle. How it appears, you see here. Uh, see, now look at this Karplus curve. So if you see what is the meaning of dihedral angle, then we'll go for Karplus curve. You see the book to understand the dihedral angle in the molecule. So we have shown here one molecule. This is the molecule. You see, okay. This is the molecule. You see here, if you consider this bond of carbon carbon, this is a carbon, and this is also carbon. Okay, right? And this hydrogen is attached to, through this bond and this bond. So you see, uh, these the orbital. This definitely this carbon is sp3, right? Yes, this carbon is sp3 carbon, right? Yes, and this carbon is also sp3 carbon. So this orbital, which is due to overlapping with this orbital of the hydrogen, is like this. This bond is forming by sp3p sp3s overlapping. This bond is also formed by sp3s overlapping. And due to this overlapping of orbitals, these two bonds they are parallel like this. See, if you draw like this, like this, like this, and you go like this, they are parallel or not? Yes, they are parallel. They are parallel. Okay, like this. They are parallel to each other. So when the bonds they are parallel to each other on the carbon, adjacent carbon, like this and this and this. So such bonds are called as a bond angle of 180. So you see here, this this is the carbon carbon bond. This is the carbon carbon bond, and one hydrogen at here and one at this side. This bond is called as uh, parallel bonds, and the angle between these bonds, angle between these hydrogen to hydrogens, is called as the dihedral angle. So you can understand by taking the this book, you understand the book. This middle line binding side of the book is this carbon carbon bond, and these pages, you consider these pages, all pages are this, you consider all pages as the different hydrogens are there. And if you see, if you go by just going to one by one page, left side or right side, okay, turning the pages, so you see bond angle will, what will happen, there will be the change in the bond angle, right? Dihedral angle. So what is the simple idea of dihedral angle? What is the dihedral angle? The angle between the hydrogens of two adjacent carbon, that's all. The angle between this angle, the angle between the hydrogens of two adjacent carbon is called as dihedral angle. So this idea is given by Karplus, and see, it is a very much, it is of very much importance, and very great uses are there. So we will discuss now further molecule. And remember, by using the Karplus curve equation or Karplus curve diagram, we can find out the stereochemistry of the molecule. We can find out the conformation of the molecules also. Okay, axial, equatorial, many things are we can see now. Okay, so see here, one more bond angle is here. We can write this bond angle in this form like this. We have shown you green words. These two are, they are what we say, anti to each other, or 180 angle. And in the, what is this? Can you tell someone what is this projection formula? Whose projection formula? It is the
Newman
Newman
projection.
projection.
very nice, very
Newton
nice.
by projection formula.
Human projection formula. So you see, if you see this form, this structure from this side, if you are here, suppose if you are here, okay, if you are here and you are watching this molecule from this side, so it will appear like this, back to back. This front carbon, rear carbon to your head, near to you is a rear carbon and with the front carbon. So like this we can we can label this molecule, we can transfer this molecule to Newman projection formula. We have idea about Newman, Sahar's, then we have Fischer projection, right, Wedge projection, and Haworth projection. Many projection formulas are there only to represent the stereochemistry of the molecule, or we can say three-dimensional structure of the molecule. Now you see the two hydrogens which are opposite to each other. Their dihedral angle is 180, and here also 180. They are just opposite. How to get the idea that two hydrogens are opposite? Just have a straight line. You straight line, you draw a straight line, you will get straight line. We are connecting two hydrogens with their 180 angle. Very simple idea, remember it in mind. Okay, fine. So when two hydrogens, they are having angle of 180, so what do you say about them? So remember, don't forget, largest 3J values. You are getting the point. When two hydrogens in the molecule, they are at on 180 angle of dihedral angle. If they have 180 dihedral angle, just shown here in two examples, so it means that they have largest 3J values. So it is fixed that, because what is the reason behind that? Because when the two hydrogens which are dihedral angle to each other, so these two parallel orbitals, our aim is to understand the coupling first. These two parallel orbitals, they have very beautiful coupling between them. Very effective coupling will be between these two protons which are non-equivalent. Okay, so very beautiful coupling, very strong coupling, very effective coupling results in the higher value of splitting, and that is called as a J split. Fine. If angle is J 180, J value is largest. Remember this point, don't forget. Okay, now this is the Karplus relationship. Very excellent. This graph, very rough graph, but it will give you very accuracy in your determining the stereochemistry as well as the conformation of the molecules. You see on this axis, you can see here, uh, you see on this axis, we have on this axis, we have this angle of diagonal angle. On this vertical axis we have the what should we say, the J values. Okay, coupling constant J values here at both the side, no problem. So now we see, when we have the angle of 90 between the two hydrogen, if the angle is 90 degree, so what is the value of J? You can expect from this graph, 0. You see, if angle is 90 or around that 92, 89 like that, almost 0 means there would be no splitting. What is the reason behind that? See, understand the point. Though the protons, neighboring protons, they are not same, therefore they will couple, but there would be no splitting if the bond angle or dihedral angle between them, not bond angle, dihedral angle between them is 90 degree. So such protons will not couple, or we say they will couple, but they will not split. The reason is very simple. At dihedral angle 90, at dihedral angle of 90, you see here, we can say, you see this axis, or this axis represent the coupling constant value, and this axis represent the dihedral angle. So what will happen here in the case of this dihedral angle? We can say that if you think about the uh, 1 minute. If you see this dihedral angle 90, so there is a one proton, suppose. Sorry, there is a one proton which is at which there are two protons. Sorry, actually I'm trying to take a here annotation के लिए I'm trying to take a paint, but now I got it. See now, see there is one proton, there is a carbon, and here one proton, and there is a one proton here. Suppose so, in the molecule we will see the structure. See here, two protons. So see here one carbon carbon. So if you see, if you how to connect them, very simple idea. So if these two protons which are at 90 dihedral angle, so there will be what will happen here. So here there is a orbital here where there is orbital one proton and another orbital of another proton is like this. So there is no interaction because it is orientation in this direction. It is in this direction. So there will be no sensing of coupling, no sense of from each other, and hence they will not split. So very simple to summarize this idea. Very simple. You see here, when angle is zero, means there is a very good coupling, effective coupling, very good splitting. J values you will find here. And as angle increases, J value decreases up to 90 to level. And after 90 again same thing will happen. As angle increases, J value also increase as you, and at 180 you will find that the highest value of J. Just last in the last slide we have seen it, right? If you connect this is lowest and this is the highest. So we can say that at 180 angle, at 180 angle, the maximum J value would be shown by the molecule. Okay, this is the Karplus curve and the J value. So hope you understand this idea. Fine, right? Yes. J maximum, yes, we can say, right, you're right, correct. We can say maximum J value, J maximum, J maximum. Fine. So now, see here, for example, you see these two carbons are there, and consider these two protons. Suppose they are not equivalent, they are not same, they are different. Suppose so, you can see what is the bond angle between them? Zero bond angle, or we can say non bond angle. Dihedral angle is zero. Best example is what? What? This is in the Newman projection, eclipsed protons. Remember this point. In the Newman projection, eclipsed proton would show the 0 degree of dihedral angle. When they have 0 degree of dihedral angle, so what is the value? They show definitely very good value of J, very good value, very effective. Why? The reason is very simple. These two protons, which are having their orbitals like this, they are in the orientation of each other, and therefore they will sense coupling from each other and they will split. Fine? Yes. Similarly, if you go for next one, if you go for the next one, see again, extreme example. These two protons which are having 0 angle, here they have 180 dihedral angle. When they have dihedral angle of 180, their orbitals orientation is very effective. Their orbitals will sense with each other. There will be coupling between the protons, and then therefore they will split according to the neighboring n+1 rule. We have seen many examples, right? So no need to get confused, no need to get worry about it. Just have an idea that what is the effect of Karplus relationship, and we know the type of protons. Right. Next one. Now see, this is the Karplus equation. Now so, see, based on the Karplus equation, how we can find out the conformation in six-membered ring. This is a very challenging task before a chemist to identify the conformational analysis to find out the group is present, how it is present. Axial, we know in cyclohexane, we have the two types of hydrogens, axial hydrogens and equatorial hydrogens. If we replacing the hydrogens by certain groups, so we can call a group R of two types, axial groups and equatorial groups. But when we perform the certain reaction, एक रिएक्शन हमने किया है एंड प्रोडक्ट हमको मालूम करना है कि कौन सा प्रोडक्ट आ रहा है, because उसकी physical parameters we don't have right now. We don't have apparatus access to that. Suppose parameters, physical parameters बाद में मालूम करेंगे हम. As a chemist, organic chemist, we don't know what is the physical parameters. कि what is the energy of that. We don't have idea. Just आपने क्या किया? You just have put the reaction. We entered into the lab at 2 o'clock. As usual time in Pune College Chemistry Lab. You have collected all the chemicals one day before. You have already you have put every chemical on your working table. You wear apron. You use goggles, safety goggles. You are with your safety shoes. You have a very good ventilation source in the lab, and you have started the reaction. Or we will take example, and you got the product after 3:30 while talking with your friends and roaming here and there in lab, collecting the chemicals, getting the TLC plates, and after asking me, so please help to cut the TLC plate, and you are getting that plate, you are pointing the you're giving the point on the TLC plate by the pencil, and you have ready solvent for the flow, and you went to the your neighbor lab, Bajuki lab, and you have seen the UV lamp is also working well, everything is there. Okay, yes. And you have now you have started the calculation, you got the idea that how to millimoles and how millimoles reactant will react with each other, and we will get the product after 2 hours, 3 hours, depend upon the situation. And let us take example, we will see example, and you got the product, and now you have one more access. Like suppose in our college we don't have right now, but in future inshallah we will have very soon. We will have that in future, we will have that. So NMR instrument you have, this is my point. You went to NMR spectrometer, and you are own you are the very good technician. You use your chemical, you use your compound prepared, आपने उसको purify किया, and you have taken that into NMR tube. Imagine you are doing this, and you went into the NMR instrument lab. You got the NMR spectrum, but questions remain. There are two possibilities. Theoretically, you say there are two possibilities of the compound product. Which will be the mine? तो दो possibilities थी, तो based on that NMR spectrum you can easily judge at that time, before leaving the lab, before leaving the college, this is this molecule, this is the research, so we will see example here. You see trans diaxial hydrogen atoms जो होते हैं in cyclohexane, we are talking 6 member में cyclohexane, cyclic rings, ring cyclic structure. So we know trans diaxial hydrogens atoms are at 180 degree. Neighboring hydrogens की बात हो रही है, neighboring hydrogens, okay, diagonal angles to each other, hence have largest table. So this is the basic idea. This is the basic concept in cyclohexane ring compounds. You got it? Yes. ये basic idea हमको याद होना चाहिए आप लोग. What is the basic idea? Yes, that this is the basic idea. This is the basic idea. इसको भूलना नहीं है, right? Now see now, isn't it cyclohexane ring? Yes. And
Yes.
this proton is axial, and its neighbor is this axial, right? So are they are 180 or not? Yes, they are parallel. If you
Yes.
yes, they are. See, you draw like this ring, straight line. This will go like this. So they are parallel to each other. Yes. So this is what we are expecting now. Okay, fine. So now see. So their angle is of 180. These two hydrogens, which are shown in black, have what is it, had 180, hence can be identified with the largest coupling constant, is 10 to 12. Remember this point. This will be our reference value, because we have a lot of work on cyclohexane here, and you are in future also. Many scientists are working in this area. Now you see these two hydrogens which are shown in black, they are neighbor to each other. We are not talking about other hydrogens. Okay, यहाँ का third fourth carbon का we are not talking. We are talking 1 2 carbon hydrogens. So J values is of 180. One more hydrogen possible here. You see, what is another hydrogen possible? You see, there is one more hydrogen here. One possible that will be also like this. You see. Right? Yes. So for this will be what? Yes, at 180 degree, right? Isn't it? Yes. And इसके लिए ये होगा for this hydrogen 180 ये होगा and 180 will be this one. Fine? Yes. So understand the idea. Think about it. Now next point. You see this proton and this protons. Are they axial to each other or they are axial equatorial? Yes.
Axial equatorial.
Yes, they are. Yes, yes, very good. So, what is the question? See, focus on the concept. Will they have angle of 180 or less than 180? Fast.
Less than a 180.
Very nice, very nice. Less than 180. Let me tell you, if some of you will have, sir, I don't have how to write the bond angle. Let us have a clear cut idea. See, we until unless we don't have a clear cut approach, we cannot understand. See, let me tell you how to find out 180 angle. Sir, I'm for example, someone is there. Adil, sir, I'm not understanding. Please explain me. Take me to a break, a very basic. So I will take. Don't worry. What you do? You cut this hydrogen from here. कट कर दो. कट किया आपने. Yes. ये हाइड्रोजन कट किया आपने. ओके राइट. एंड हमने इसको ऐसे रखा है ना कट करके. यस. एंड okay, 1 minute. What I will do? I will show you. See, cut this hydrogen and put here. Okay. Okay, right. Now what you do? Cut this hydrogen also. So इसको कट किया आपने ऐसा एंड लाइक दिस. एंड क्या करो? ये जो पॉइंट है, ये पॉइंट इसको हलाने का नहीं, वही डायरेक्शन में लेकर आओ. इसको इधर खींचो आप. सो नाउ यू सी इसको अगर आप आगे लेकर आओगे, सो व्हाट विल हैपन? दिस विल बी connected to like this. Isn't it? Yes or no? Yes.
Yes.
And you see ये आपका पॉइंट है, ये यहाँ से यहाँ मिला. व्हाट इज द एंगल? 180. 180 एंगल. ये 11 8 9 10 का कंसेप्ट है. Now how to do, sir? I am unable to understand this. What is the bond angle in this? What is the bond angle? So you see 180 है कि नहीं? So you draw this. ये इसको यहाँ लेकर जाओ. You remove this bond and you will find it. You see. What do you think about it now? You tell me. What do you think? Is that you see? ये जो angle है, is that 180 or less than 180?
Less than 180.
Even less than 190 also, isn't it? Is the even was then less than 190, 90 also 90. ऐसा
90.
90 से भी कम है. 90 ऐसा
Hmm.
रहता, 90 से भी कम है. समझा आपको? Yes, yes, very good,
Hmm.
very good, very good. Right. No, next one. See, so what about this two again? Again, same thing. See, don't worry about it. Same thing, very same. What do you think? See, you consider this bond. Break this bond and take it in this direction only. In this direction, you see, ये ऐसा आ गया, ये ऐसा ऐसा आएगा. Sorry, ये ऐसा आएगा कि नहीं आएगा? Yes, yes. So is this 90 or less than 90? Less than 90.
Less
Fine.
than 90.
Very good, very good. So clear, very nice. Now see, let us have to go discussion. So when two hydrogens which are both equatorial to each other, these two are equatorial to each other, or when they are equatorial axial to each other, have dihedral angle about 60. You getting the point? समझा? Yes. सबको समझा है? Yes.
Yes, sir.
Very easy, very easy. So we got idea that the two hydrogens which are at diagonal angle to each other about 60 degree, their J value decreased from the Karplus angle. You think about Karplus equation, you think about Karplus curve and produce your answer. So when two hydrogens they are at 180 angle, they show the maximum J value, that is 10 to 12. And if they are not, see, if they are not at 180 angle, they show lower value. Simple idea रखिए ज़्यादा, Mr. KVN companies, समझा आपको क्या? Very simple idea. So in cyclohexane we have only two approaches. Clear cut idea. We have only two approaches. Axial bonds of neighboring protons 180 highest J value. If they are not axial, lower J value. Feel clear? Clear approach. Clear approach, right? Okay, fine. Okay, fine. You got it? Fine. Let us go for next point. Let us go for next point. See the example. See this example. Yes. Now see the consider this example. Application of right angle. Now see this is the molecule. This is the molecule. But question is one more possibility is there. It is equatorial here. If we put here axial, so we'll study this first. You see this one, black hydrogen in black. How many neighbor it have? Two neighbor, two neighbors are here, two neighbors are here, right? Isn't it? Fine. Right. So how many of them of axial? Here will be axial, here will be axial, and equatorial will be like this. So we will see that. No problem. See now, axial, axial, and hydrogens, right? So
Yes, sir.
now first let us see this. So how it is split? Always remember, we are doing this, we are discussing, we are studying this molecule at low temperature and not low also. It is okay, not zero, because this group will lock this molecule. Cyclohexane को lock कर देगा in this part. Now you see, this hydrogen will split couple with this by n plus 2 rule, n plus 1 rule, and how it will form? How many n? And how many n? N plus 2 rule. Yes, n plus 1 rule कितने? दो है. 2 plus 1
Three triplet.
triplet. But one point. Remember triplet. But there are equatorial bonds also, isn't it? There are equatorial bonds here. So equatorial का अलग एक सेट होगा and axial का एक सेट हो गया. So this proton. See what yesterday. It is the connected question to Faiza's question. Connected concept. What she asked yesterday. This is the same idea. This proton will have two sets. One is axial set, one is equatorial set. So these two protons are neighbors, one set. So by n plus 1 rule, this will split first with this and then with this also. But question is, पहले किससे split होगा? Axial से equatorial से? Yes, बोलिए. Faiza and all. Faiza is not there today. Fine. What do you think? This proton first couple with whom? Axial or equatorial? No.
Yes,
Axial,
sir.
sir.
I'm here.
So, acha, I think you have got it.
Axial.
Axial, why is correct? Why Farat? Why axial? Because
Uh,
Because it's near.
Equatorial.
equatorial. Why? Why equatorial? Why equatorial? Yes.
So maybe axial because it's more near to it.
No, अभी हमने पढ़ा है. अभी हम देखिए. Yes, you think about it.
The largest coupling at axial.
That is the reason. देखिए कभी भी छोटी चीज बड़ी चीज से निकलती है, बड़ी चीज छोटी से नहीं निकलती है ना. So when there is a first of all there is a coupling with हमने देखा है ना इससे पहले का. If you see this one,
Hmm.
you see one minute I will show you. अगर आप लोग भूल रहे हो तो फिर वो means there is not good. See, one minute. Oh, अभी lose हो जाएगा. See, okay, give me 1 minute. So you join after again 2 minutes क्योंकि I wanted to show you that slide लेकिन थोड़ा hang हो गया है. So you join after 2 minutes, 1 minute. Okay, fine. We will back. So yes, can you hear me all?